All right. Once again, I welcome you all the participants here in this session, as well as our today's expert, Mr. Vijay Singh Saran, who is from BHEL. He is a senior manager there. So, before starting the session by Mr. Vijay Singh Saran, I wish to read his credentials. So, let me read the credentials of Mr. Vijay Singh Saran.
Whether they
So as I was telling that he is my close friend, and we used to discuss many of the points, starting from the research, academics, and sometimes politics too. So in our language, I must say, since many of the people are here in the meeting from Bikaner and from Rajasthan, so they might be knowing that one of the term in Rajasthan about the close friend, and that is Baila. Do you understand Baila? Many of the people are not understanding. Is there anyone who is from Andhra or maybe somewhere from Tamil Nadu, Kerala? What do you say a close friend? In general, in Rajasthan, we used to say them Baila. Anyway, so it was just I was just passing the time, and only I'm just reading out his citation. So once again, welcome Mr. Vijay Singh Saran here in this session. So actually, Mr. Vijay Singh Saran is working as senior manager in power sector, Western region, a wing of BHEL, Maharashtra PSU, Maharatna PSU, having more than 17 years of power plant professional experience in handling 500 megawatt, 660 megawatt, and 800 megawatt sets of multiple states utilities and private developers like Adani, MB Power, etc. He is acquainted to first-hand experience in assisting strategic positions, primarily responsible for construction of more than 7 gigawatt of capacity addition thermal projects, around 8 gigawatt standalone FGD sites for valued more than Indian rupees of 10,000 crores. He holds a bachelor degree in production and industrial engineering with honors from Rajasthan University in 2004, subsequently recognized by professional certificates of level 2 in NDT, pursuing international certification of project management professional, special initiative program on Harvard Managementer by SCOP, Conference of Public Enterprises, an apex body of DPE for identified PSU professionals. His current interests are implementing the learnings of experience in expediting thermal project execution cycles, identifying technological developments for autonomous of inside welding, coal to chemical technology, etc. He is firmly committed to advancing technical excellence and fostering modern engineering practices in India's evolving power sector. So this much of experience and this much of certification, I once again welcome Mr. Vijay Singh Saran for this today's session. And now I invite Mr. Saran to please present yourself. So I
thank you,
hope,
Dr. Ganesh.
yeah,
I
yes,
hope
yes,
my
exactly.
screen is visible to you, all of you.
Yes, actually,
Can you
although
please
you have
confirm it, sir?
shared your screen, but somewhere it will be good if you put your mobile in landscape way. It is in some way portrait way, so that's why.
Can you confirm it now, sir?
Yeah, you have shared your screen, but there is something kind of blurry screen is there. We are not able to see. It would be good if you put your mobile in landscape mode. I mean horizontal. It is something for
I think
kind,
some
virtual, and something.
poor connection is showing in mobile. So I will start with the
Okay, I'm
PPT.
also
I
stopping
think
my video, so
PPT is not visible, but I will start it.
okay, okay, no problem. Yeah, yeah, please. If there is no PPT, there is no problem. You can simply you put your ideas simply through audio only. Sometimes it may happen that there may be sometimes the problem of network. So I think the participants please be here only. Is trying to join, and if the screen will not be visible at all, then there is no problem. Even we are able to understand the things you will deliver through audio only.
Am I audible?
Yes, 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 please.
Okay. So, like the first, what I want to say,
You are not audible, sir. Maybe you have muted yourself.
it's not muted here.
Now it's okay. Okay, we are able to or hear you.
Maybe there is some internet issue, but
Are you there? We are not able to hear you. Maybe there is some problem of internet or something else.
hello.
Yes, audible, sir.
Okay. So I will again resume this session. you please again confirm that whether my voice is audible to all of us?
Yeah, it's audible now.
Okay. Kindly excuse because I am traveling and there might be some internet connectivity issue. Is quite possible, but
Okay, no problem, sir. Participants, please be here only. I'll post the attendance soon. Someone have asked me that when the attendance link will be shared. It will be shared soon. Please be here only, here in this meeting only. Actually, there is some connectivity issue with Mr. Saran sir, so that's why this is the problem. Maybe he'll resuming soon.
connect. So that maybe some issue is there that will get resolved. I will reconnect, sir.
Yeah, sure. Okay, all right, sure, no problem. Yes, sir. Have you joined now? Vijay sir, have you joined? Actually, I am not be able to hear from you. Whether you may be there in the meeting only. Now, am I audible? Actually, you are here in the meeting, Vijay sir.
So could you please?
Yes, you are audible, although a little bit breaking your voice, but it's fine. So if I am audible, Vijay sir, are you there? Actually, still we are not able to heard from you. Maybe
Sir,
you
you are
have.
audible, sir.
Yeah, yeah. Now you are audible. There is no problem. You may start now
Okay.
without even without the
Sir,
slides
sir,
also.
sir, could you please confirm through the other attendees also, so that they are also, because this is very energetic and very good session to get acquainted with the India's power scenario.
Yes, yes,
So
exactly.
if you could confirm with others, the attendees whosoever is in this discussion or meeting, it will be
Yes.
highly grateful.
So any participants, please confirm whether they are hearing from Mr. Vijay Singh Saran, who is the
Yes, sir.
expert for the
You are
session.
audible.
Okay, all right, all right.
Thank you, sir.
Anyone else? Okay, yes, sir. Someone has written also there in the chat box that they are able to hear from you. So it's okay. I think there is no problem with it. Even if there is the problem with sharing the slides and all, then you can simply put your audio only. Someone has also written that you are audible. Vijay sir, am I audible?
You're audible, sir.
Yeah, yeah, you are audible now.
Okay. So one more thing is there that the base load.
Are you presenting? Actually, we are not getting your voice. It is breaking sometimes. And should I make you host? I think I should make you host so that you will be unmuted all the time.
Okay. But in my mobile, it's showing unmuted.
Oh, so anyway, I have transferred the role of host to you. So probably you will be able to control over the things.
Okay. Let me again try for this screen. So can you confirm that one?
Yes, sir. Screen is visible right now.
Yeah, yeah, it's okay. Oh, very good. So I think you have started early, but we have not got the earlier slides. Yes, exactly. Now it is visible. Oh, you are on 13th slide. Yes, yes, great. Yes, it's wonderful, sir. Now you can present. Yes, please. Still, your voice is not coming. You are not able. We are not able to hear you,
I don't know what
although
is.
you are
But
unmuted. Yes, yes.
yeah,
Now
I am
it's okay.
unmuted. What is happening now? Whenever I used to shift the screen, like I think maybe this
Okay.
voice is not getting there. Screen is visible.
Okay. No, but now it's blank screen. Black screen is there.
Screen it is not visible right now.
It will be better if you can simply present by audio only. There is no need if there is. Oh, okay, but we are not able to see the slides.
If sirs will share the PPT on mail, we can also share this
Yes,
slides.
exactly. That will be great. Yes, yes, exactly. So, Vijay sir, I am sharing your PPT from my way, from my side. Then you can present from there. You will be able to see the screen. Is it all right? Vijay sir, am I audible?
Yeah, yeah, you're audible, sir.
Okay, okay. So let me share from my side. Your PPT is there with me. Let me share, then you can explain from there if it is possible.
So I have set the role also. I disconnected the sharing right also. So you can share
Okay, okay.
your side.
Okay, okay, no problem. Okay, let me see where is your PPT you have sent me today. Okay, let me share from my side. Actually, earlier that was on WhatsApp. I have sent them that to in my mail. So I think now I have shared from my side the slides of Mr. Vijay Singh Saran sir. So probably Vijay sir, is these slides visible to you?
Yeah, it's visible to me.
Okay, okay, all right. So now from here onwards, you can present from these slides. So okay, yeah, you can
So,
please
sir,
start now.
I will guide you to go for second slide. According to
Yes.
next one, with word of next, you can go to next slide, sir. Yeah, yeah. It is the basic like in what way I am thinking that first we have to understand the energy source in India, the source like from where we extract the energy. For in Indian scenario, as we can see from this pie chart and this graph, that around 57% energy power supply source is belongs to coal, and the other factors also I put. And to particular to restricting this session, as you can see that for renewable and hydro, it is energy source, because we are not utilizing this solar source as of now in India. Though we are having adequate capacity for no, but we are in initial stage, like as earlier I told you. And for the last 7 or 8 years only, we have means many of the power developers, the government of India has put more emphasis on installation of this solar power plant. So it is the first slide. So can we go to the next slide, sir?
Yes, yes.
And suppose any question is there, the attendees can ask. If they are interested to talk at later stage or through email the query, no issue. Then I can reply at later stage also, and I can reply through email also. No issue. So I will proceed then. In this second slide, I have put some remarks regarding the installed capacity in India, and showcasing the capacity growth of capacity addition since 2019-20. As we can see from this particular page, that more or less the thermal capacity addition, thermal power plant capacity addition is stagnant. It is around 2 lakh 40, 2 lakh thousand megawatt. Instead, this solar, which was around 25, 10, 20 2000 megawatt, now 20,000 megawatt. Now it is around 1 lakh 25,000. In the last pillar, where I have put this 5 lakh megawatt, basic structure power capacity addition from is standstill for last 6 years, but the installed capacity of solar has expanded multifold, or we can say exponential growth, which was around 2019. Now it is around 1,25,000 megawatt in this year. And to noteworthy here, I have put few good stats also, which will come in the next slide. So this is the slide where I have given this brief or a small idea about the installed capacity. Because to understand the impact of thermal plants on renewable, first we have to understand the scenario of the power scale of India.
Wait,
So,
wait.
sir, can you go to next slide, sir?
Yes, sir.
In this, there is one plant load factor. Plant load factor is basically the availability or the load factor, the availability of electricity generation for catering the need of demand, catering the basic grid demand. You see that few this yellow line, the bottom line, it is in some 2014. Initiated in India because of government of India intervention and some international interest. So as we can see here in the last point, the last bullet point in 2025-26, we can see that more or less this renewable coal-based power plant and the nuclear-based power plant, the red one, black one line shows coal-based. These are two lines are more or less segment-wise. It is around 80%. So we can say that if as a plant is there for coal or nuclear, for suppose more or less 80% to give supply or give generate the power, where the solar plant, it is the bottommost, it is around 20%. Means if suppose 100 gigawatt solar plant is there or solar power plant capacity is there, so we can extract only 20% of that. That is 20 gigawatt. Means 20 gigawatt means 1 gigawatt will be around 1000 megawatt. So 20 gigawatt will be 20,000 megawatt. So which means which indicates that if I have installed 100 gigawatt of solar power plant with the certain assumptions that land space, the output from this efficiency of the solar plant, which is around 15 to 17 or 20% only, in place of coal's 40, 35, 40, 42%. So that total plant load factor for solar is only 20%. Though India is having very rich supply source for availability of solar power, which I covered in, I think, in some other slides. So this is the concept which shows that the solar plant are not available. Their load factor is around 20%, whereas this coal-based and nuclear power plant is having sufficient and very good plant load factor, which is very helpful or very connected with the base load requirement of government of India or our national grid. So I think we should go to next slide, sir. Yeah. So here I have mentioned the installed capacity, though there is some plant is there, we have to extract, we have to generate some power. So I have put that to also 2019-20 so that anybody can correlate like the installed capacity from 2019-20 to 2025-26 and corresponding generation also. Here you can see, although the installed, I think someone is
Vivek
not
is there.
muted here.
Someone Vivek Kuswa, are you there? Actually, you please mute yourself. Okay. Anyway.
So, sir, one thing what I want to especially mention over here, but I also put that word earlier also. So this thermal power plant capacity is, but the generation, because plant load factor is 80%, so generation is around 70%. Plant capacity is 50% in India, total thermal power plant, but generation is 70%. Whereas, which is around 125 gigawatt in India out of 500, around 25 solar itself. Renewable wind is also there. So from say out of 125 gigawatt, we were able to extract merely 25 gigawatt plant capacity only, which is as we can see here from the, if we call generation from solar or from renewable is quite meager, quite less, quite dismal in place of, while comparing with base load plant like nuclear and thermal coal based. So anyway, all know that we are moving already 25 years we have crossed in this 21st century, and for growth, strategic growth of country, availability of power or infrastructure segment is very crucial, and corresponding availability of power to match the country's requirement in other segment like in industrial or other segments. So availability of power is quite crucial, so that growth, if we expect that solar will help out in next 2 or 3 years, it's quite typical. Means it's quite impossible, because the base load in India is around 3 lakh megawatt, and present installed capacity is 125 gigawatt from solar, whereas we can extract only 25 gigawatt from that. So that 25 gigawatt will not going to cater 300 gigawatt of power requirement, peak load requirement. So with that concept, we can understand as of now we are because of this solar power or renewable power is green energy, and government of India and across globe also everybody is seeking this clean and green energy. So with that we can go to next slide. The only point what I want to mention here that the availability of or generation of power through renewable is quite less as compared to the stable load or the base load units like coal and this nuclear. Yeah, it is just a simple slide where I put out a few things regarding the peak load, base load, or the demand. In peak demand, as you can see here in the earlier 3 or 4 columns, earlier it was peak load in India at any moment was with the grid. This peak demand is at grid level, means the supplier consumer side. It was around 172 lakh megawatt in year 2017-18, whereas it exponentially increased to around 240 megawatt, 240,000 megawatt in 2025-26, which is quite like I don't think it will going to cross the last year's mark, that is 200, I think 249,000 megawatt. So what I put point here that peak demand was not increasing for last since 2015-16 to 2017-18, or we can say 2019-20 as well. But after that, suddenly there is a rise of around 25 to 30% peak demand at peak season. Even though this peak demand is also not being catered, there was a deficit also. So during this period when peak demand was ranging between 1,70,000 to 2 lakh megawatt, at that moment thermal power plant construction was prohibited by government of India because of certain assumptions that we can match the country's base load requirement through available thermal power plant sets with the addition of renewable segment. But during this stage only in 2019-20, CEA has given one paper and pointed out to government of India and or given a flag to India, rising flag to India that see, if we will not go for a thermal plant capacity addition, then it will be a issue because it will not going to the renewable power will not going to cope up with the country's growth, and that can only be sufficed with the support of thermal power plant. So from 2019-20 or after the CS paper put it in front of government of India, there was a special drive from government of India to install the new thermal power plant sets. So this is a few points I want to put over here, that peak load, peak demand grid increase in last 4 or 5 years. That too we are having deficit in power peak demand. So can you go to next slide?
Yes.
Yeah, sir, thank you. Like what I was saying, there is a capacity, then there is a generation, then definitely there is a point, the consumption. Here, these numbers we can see 2022 to 23 and 2023 to 24, the consumption is increased from 14 lakh 40,000 million unit to 15 lakh 43,000 million unit. So there is around, if I can calculate very fairly, 7 to 8% consumption increase in last, between these 2 years. And I have mentioned that the segment-wise consumption is also there. The bottommost is agriculture, which is more or less flat for last 10-12 years. There is only increase in industrial segment. I think the black one, industrial segment, as you might be seeing over here. So because country is showing some growth path, and accordingly consumption is also being increased by industrial due to industrial growth, which is being taken care by with the support of thermal, renewable, hydro, nuclear, all installed capacity of India. That too, if we can put this thing for a futuristic view for 5 or 6 or 10 years scale, this consumption will also going to increase, and correspondingly we have to the person, the authorities, the nodal agencies whosoever connected with this particular point, uh, they thought that if we will not going to install thermal power plant or renewable power segment, we will not give some boost. Definitely, we will be this deficit, which is around 3 or 4%. It may go up to 10 or 12%. And with this deficit, electricity deficit, we can't expect that growth in India's scenario, what government of India is projecting. So this is the only point which was I want to mention here, that there is an increase in the industrial, although every other segment is more or less constant, including some there is increase in domestic also, but industrial has shown a very good increased path for consumption, matching with the corresponding generation. Yes, sir. You can go with the next slide, sir. Okay. Here I have put this particular slide regarding capacity in megawatt. This slide shows that addition of capacity addition of energy, electricity. As we can see here, 2015 or 2017-18. Earlier, up to 2015-16, there is around 20,000 megawatt annual capacity addition from thermal. But after that, there is quite dip in installation of a thermal plant, as I was mentioning earlier. But at the same time, we can see 2017-18 onwards, there is a rising trend for installation of solar plant. As we can see here, to quote few points here, 2024-25, India has installed some 33,000 megawatt plants. Majority of them belongs to renewable. And in this particular financial year, the present financial year, ongoing financial year, FY 25-26, we have government of India has able to add around 26,000 megawatt. That is majority from solar, either from large scale solar plant or the domestic or rooftop panels. So it shows the drive or the impetus government of India has put on relying on the renewable power extraction. Okay. So, sir, you can go with the next slide, sir. Okay. In this particular slide, as we can see here, there is nothing between in 2019, 2021, 2023, 2024. The capacity of coal power plants, coal-based thermal power plants, because there was a mindset, there was a thought that no, we are adequate with the available capacity addition, the available installed capacity, and we will not going to require any further coal-based power plant. But at the same time, when I was saying earlier, like the CA code, after that, government of India has given some 37 or some 97 gigawatt capacity addition target in line to CA's directive for next up to 2025, from 2024-25 onwards. So accordingly, government of India has set some target for installation of or construction of new coal-based power plants, which is ranging yearly, as we can see, around 12 gigawatt, 12-15 gigawatt annual basis, around 10 to 12 gigawatt annual basis capacity addition target is given by government of India, highlighting around 97 gigawatt up to 2030. Means around 97,000 megawatt will be added in grid or installed coal-based power plant to cope with the country's increasing requirement or demand. Okay, so you can go ahead, sir. Yeah, as we all know that the fossil fuels have a larger impact on the emission. Accordingly, phase-wise, government of India has diluted some coal-based power plant, and these mentions means as we are planning to add something. At the same time, we are deleting some old power plant which are not beyond repair or beyond retrofitting. Okay, sir. Ganesh, sir.
Yes, please. Yeah.
Yeah, this is very beautiful, because Rajasthan is there. This particular slide, what I want to see that at the right side of this slide, there is a number 3343 gigawatt. Means in India, considering the landscape of India and the demographic with from solar, we can extract around 3300 gigawatt solar power. So we have installed 125 gigawatt only. Majority of at the left of bottom, region wise there is distribution. WR western region means Rajasthan and Gujarat side, and the southern part, the coastal area and like this Andhra and Tamil Nadu and Karnataka, they are more on this available. What I say, they are having more potential to meet this 33 gigawatt number. Although we will not going to touch this number. Other more crucial other different parameters also. So government of another 25 to 30 years. Accordingly, they will install the plant. As of now, government has, I think, set some 300 gigawatt target up to 2030 from solar. So with the number which is presently 125, it will be around 425 gigawatt by end of 2030. Okay, sir, you can go with the
Yes.
next slide, sir.
Yes, yes, please.
It shows state-wise power generation and the consumption also. Wherever we can see that the numbers are more or less they are equal. The generation or more or less. Next slide, sir.
I have changed the slide.
Yeah, here we can see the scale of globe on a flat screen. Here we can see that India has invested or imported coal from across the globe, valued around 3,17,800 crores, and the quantity is around 265 million ton. So this is a very crucial slide because government of India is giving more focus on relying on whereas number 3,70,000 is more or less it is 3% of to change this segment. Now we will, because India is rich of by best of knowledge.
Is there anyone wish to ask
Is there any
something?
query?
Okay, I think it was that was by mistake only. Okay, Dr. Amish Suresh.
Am I audible, sir?
Yeah, yeah. Yes, please proceed.
Okay. I want to add here, like earlier, what we used to, or the power developer used to do, they used to import the imported coal from Indonesia, Australia, and subsequently it is a country issues, disputes, and the thought that countries for growth of our own India. So, particular this segment, we can understand that a very good amount, handsome amount of economy is going to other countries. So now, because India is having rich of coal, though the GCB of coal is not adequate, but the known or the coal is around, if I'm not wrong, it is around some 260,000 million ton, whereas our annual consumption is around 1,300 million ton, considering 250,000 gigawatt megawatt in India. So if we get it up to 350 gigawatt, the number will go. It will be around, if I'm not wrong, it will be around 1,500 or 1,600, between 15 to 60. So 1,500 to 1,600. So it we can cater the country's coal requirement or the availability of coal for next 150 years. So, sir, next slide, sir. And this 265 is around 15% of total annual consumption. So for 15% of annual consumption, we are investing 3% of national economy to other countries. This is Indian power sector current energy mix. Here, things that India's installed capacity, as I earlier told you, that highest share of coal-based power plant is 50%. Which reflects into higher reliability of power or availability of power. Rapid growth in renewable energy, as I earlier told, that in last 6 to 7 or 10 years span, we have there is a great leap in generation or installation of renewable energy sources. So, though there is one point that these renewable energy need operational flexibility. Operational flexibility means basically renewable or power, it depends upon demographic conditions, atmospheric conditions. The 24-hour day span is the availability of power can be extracted from these renewable energy for around 6 to 7 hours only. Okay, and the connection of this power with the grid will give flexibility, will not give any flexibility for meeting any demand from grid side. Accordingly, for this current energy mix, I will say that thermal units remain essential. Everything is crucial, but thermal units still remains essential for balancing the variable renewable result into less absorption or acceptability. As we all know that this renewable power or solar power basically is a costly affair. As of now, after a lot of years engineering and technological developments, and the Indian domestic coal, we have reached up to around 3 to 3.5 rupees per unit rate, whereas solar power is still beyond 5.5 rupees per unit. Also, the initial capital cost of solar plant is quite high, and its life cycle also, what I earlier told you, that 5 to 10 years is the life cycle. And there is one big issue is also there, like as we all know that thermal power plants waste is ash, which we can utilize in industries. For solar waste, like the panels for photovoltaic waste, also the rare earth waste is. There is no clear-cut demarcation of guideline or directive from CERC, like in what way we have to dispose of this solar panel waste. The same case is live with the nuclear, though there is some written document from competent authority. But in case of solar power panel disposal, there is no clear-cut directive of technical instructions from Government of India or CERC. So that is the reason less acceptability also. Coal dominates generation, as I earlier told you. Coal maximum generation, around 70% generation of India in any year belongs to coal plant only, while solar and wind are rapidly expanding. This is good thing that renewable power is increasing, which can help at later stage when when our base load will increase from 3 lakh to 5 lakh megawatt. Then definitely the availability of renewable power will help government of India to maintain the base load. Accordingly, the variability in renewable energy requires dependable thermal support, because as I told you that there is a base load. So for base load, the plant load factor is around 80% for this coal base and nuclear, even hydro also. There are new technology developments, but case of this renewable, there is no such thing for variability. Like out of 24 hours, around 16, 18 hours, we can't able to extract the power. So it is the case, variability is there in renewable. Even we can't shift over to solar and wind accordingly, because they are very few time, very less time it is available to extract. Demand growth is driven by industrialization and electrification. That also I point to cover. That the growth or the demand, the grid demand, is being driven because of industrialization only. Because domestic or agriculture is not shown any this rapid increase trend, so that we could have thought for other options, but it is not the case. Only industrialization is focusing or giving this idea to demand the increase the demand. Few things in this present Indian power sector, few points that support. Sir, will you go to the last slide, sir?
Okay, should I
Yeah.
proceed for next slide?
Yeah. This is okay, sir. This flexibility, energy storage, and policy reforms. These are the points. Few points which I want to mention here. For current energy, India's power sector, these 3 points are very crucial. The policy reforms and the flexibility of generation and the energy storage. As we all know that energy can't be stored; it can move from one form to another form. So energy storage developments is most likely to help us for utilizing renewable at later in coming years. So next slide, sir. So here I have put two things: the role of thermal plant or thermal units in power systems. That basically to provide base load and firm capacity. What is base load? I will put. I have mentioned one slide over in, I think, next to slide. Provide base load and firm capacity. Thermal plant is helping out with these 2 points. Ensure grid stability. This is very vast, interesting subject of grid stability. As we all know that I think in 2011-12 there was a grid failure because of there was a difference or deficit in India's standard frequency. So with thermal power plants, it helps in stabilizing the grid. Even when this very few hours availability of renewable will also suffer or impact the grid stability. That will also be that can also be supported by thermal power, helping in frequency and voltage regulation. As I earlier told you that in India 50 hertz is the frequency and the voltage is also there. So for regulating this frequency and voltage, thermal power plant is also helping out. This is the role of thermal power plant. Maintain grid stability is the point I already covered. I think the support regional grid imbalances. I think 3 or 4 years or 5 years back, there was 4 different grid: northern, southern, eastern, western. But because now we we are progressing with some 765 rated grid, and we have established one national grid, which is helping out in different segment wise or state wise generation electricity for utilizing in different states where power is shortage. Okay, sir. Next slide. Yeah, this is 2 points: base load and peak load. What I was quoting each and every time. Base load is basically it is a common constant minimum demand that I told you that is around 3 lakh megawatt for India, supplied by only these three segments, that is coal, nuclear, and large scale hydro plants. And behavior is these runs continuously. We can operate any thermal power plant or nuclear power plant for years together, for 1 or 2 years continuously at rated load or the requirement as per the requirement of grid requirement. Whereas the peak load is short-term maximum demand. The slide what I covered, that 2,49,000 megawatt is the peak demand at particular moment and an instant when demand is at the peak maximum. That is peak load. This for any particular peak load, peak demand, people used to opt gas, hydro, and storage-based energy system because these help with ramping up the faster pace. Because I think many people might be knowing that there is a gap, there is a concept called demand and supply for this electricity generation. So for any increase in demand or shortfall in demand, we can get increase in demand can be taken care by this gas and hydro as well, including this energy storage plant also. Sir, next slide. It is ramp rate. Ramp rate is basically I put one small word. Demand. Power developer are suppliers, and grid is or the consumer is demand giving their demand. So ramp rate is basically how fast a power plant, whether it is solar or whether it is thermal. So here I put some plant type also. Coal-based power plant mostly having very slow ramp rate, that is around 2 to 5 megawatt, up to 500 megawatt set. Whereas I think at that point I cover in next slide. So the coal-based power plant up to 500 megawatt having very slow ramp rate, that is around 2 to 5 megawatt per minute. That means for from 0 to 500 megawatt plant will take maximum minimum 100 minutes, means 1.5 hours. And if the plant is old and there is issue, and it may go to 4 hours. And demand is quite volatile, I will say. It is not like that for 4 hours and the ability to generate start generation, the demand will not going to stable for that 4 hours. So the ramp rate is quite low for coal base, but what benefit is there? It is not flexible, limits accordingly. I put hydropower also. Hydropower ramp rate is quite fast. You have to just open the gate and you have to see that the mechanical engine turbine and immediately we can extract the power and through this equipment. So ramp rate is tedious process, and it will take a time to conversion of nuclear fuel into a source, a generation source, electricity generation source. Battery storage is quite easy, like as we all know that by just putting a switch on, we can extract the power. Best for managing fluctuations. This is the solution for the impact what we are having on grid because of renewable. The best alternate to grid is battery energy also. Doctor,
Yes, I have moved the slide. I hope it is visible.
suffering, I have not seen.
Okay,
So you
okay.
have
There may be some problem of
next
network.
slide, sir.
I hope you have.
Okay, sir. Please wait, sir, for this. Okay. Here, I've seen this spread section. Here we can see that a few points I have mentioned. That in current Indian performance is for old plants, maximum plant that is 0.5% to 0.75% megawatt percent per minute. For 500 megawatt, we can say that we can increase load 0.5% to 0.7% of that particular set, the generator capacity per minute. But the desired target is 1% per minute. That is to minimum. Here in the last slide, CA guidance I have mentioned that 2 to 3% ramp rate is desired or targeted, so that we can make with the great fluctuation on account of generation of power from renewable segment. So if our thermal power plant are adequate or acquainted with this particular ramp rate, we can easily increase the load. It means running a unit at 300 megawatt of 660 megawatt, we can increase load up to 660 megawatt. This balance 360 megawatt at 1 to 2 to 3% at per minute basis. Means 6% is 1%, so 12 megawatt per minute basis we can increase. And accordingly, this 360 will be within 30 minutes. So the power what we are extracting around 1.5 hour, it can be done in 30 minutes only. In 30 minutes, we can increase the load at full load, increase the load to full load. This is a desired target. As we here in second row, percentage of units. This all belongs to coal-based power plant. Percentage of unit more than 1% per minute ramp rate are merely 35%. So if I will quote that in India installed capacity is around 250 megawatt, so only 35% of units which is being commissioned latest or recently or last 5 to 7 years, they can only achieve or attain this set of ramp rate. The rest 65% are not cannot help out in increasing the ramp rate to 2 to 3%. Okay, sir. Next slide.
Can you, sir, please wind up a little bit faster because we have another session 8. Although it was
Okay. This is a few things I will cover here.
yes, please.
Because just to understand the impact of thermal units, we should understand the positive side also, the negative side also. These are the 5 points are there, which is the positive points, the advantages of thermal power plants with the while integration with the renewable energy, supporting renewable energy intermittency. As I earlier told you, 6 hours to 8 hours availability in a day from renewable. So dispatchable power. Dispatchable power is the available power, base load power, which can be catered through thermal power plant. Second is enable smoother renewable ramp up. Whenever we used to ramp up the renewable power, this base load will going to help us to available through this coal-based power plant. There is a backup because of this thermal power plant. There is a backup during low solar or wind output. Whenever there is a low solar or wind output of power generation from solar or wind power, at that moment it can be backed up through the thermal power plant. Thermal power plant help avoiding blackouts. We have seen in 2011-12 there is a complete blackout in India, the national northern grid. During peak time, suppose there is suddenly sunny day, there is suddenly a way of cloud or full of cloud. So generation will be lost from solar. At that moment, when the total that installed capacity going to dip, that time availability of thermal power plant as a backup or blackout. Supports frequency regulation under renewable. We have to maintain, the grid has to maintain the 50 plus minus % of frequency with the grid, so that it can be particular power generation source can be synced with the grid, that can be maneuvered with the thermal power plants, which is not going to happen with the renewable. Yes, sir. Next slide. These are the points which I covered as advantages. The next slide was the challenges created by the thermal units. Basically, the third emission and fuel cost counter sustainability growth. As we all know that government has put as from Paris Treaty, where we have a certain agreement with the our across the globe players that we will reduce our carbon emission in a staggered way, but of coal or generation from coal-based power plant. Solar, temperate and old put out curtailment issues in renewable heavy states. There are cases in recent last 1.5 year that Karnataka and this Tamil Nadu, this I think solar and wind power sources during at peak hours. Plant is electricity is being generated through coal base, and the installed capacity of renewable in these two states has to be put on shutdown mode. So it's helping them to instead of where the improvement has to be done and also renewable fluctuations are very fast. Temperate from thermal less. This is the operational current. It has to be looked out by the grid SDREI. Thermal power plant used 6 to 8 hours. The grid will be irresponsible from support from power support from particular unit. So it is a issue of we have to look out there. Fatigue and impact of material and equipments. So back only to pop out of nowhere. So pump hydro, and this battery storage are the two concepts. Like when the electricity requirement is less, at that time they used to earlier they used to store first this battery and the pumped storage, and at the time of less generation or less requirement, they used to pump this water to the higher altitude of dam. The gate utilize the power for this peak demand. So we can pumped hydro storage. Basically, it is a generation source which we are utilizing in battery for during critical times or the peak demand times. As path road, so that the board are operating their transmission system by their own. So if we can have that some concept or integrating the transmission system irrespective of national grid, that will also going to solve some demographical issues of power shortages and power surplus issues. And most of the thermal plants are being government is asking power developers to go for flexible operations in their CMC logics. This is very good thing. India target 500 gigawatt renewable by 2030. Total 125 gigawatt as on October 25, and around 25% in current year. Means out of this one year only. The solar is 125 and wind is 53 gigawatt out of this total 500 gigawatt India capacity. So strong in particular this year only. Increased variability requires flexible thermal generation. This is the key area where we have to many developers and engineering company has to work upon. Yes, sir, next slide. These are the few things which can be extracted during this interrupted discussion. So thermal units remain vital in India's transition to renewables. We should focus on the availability of renewable energy, because at later stage or at a larger scale, definitely it will going to cope up with the forecasted energy requirement of India. balanced policy and storage and grid reforms will shape the future. This is also one focus from government side, government of India side. Yeah, next slide, sir.
So thank you, Vijay sir. It was really wonderful presentation with full of information, full of statistical data also. So I think it is end here. Now I invite any of the participants if they have any question or any query, they can directly ask to Vijay sir. Or if they have any kind of question, you can directly post to mail ID of Vijay Saran sir. And sometimes if they are not finding his mail, you can directly mail me. I can convey the same query to Vijay sir. So thank you very much, Vijay Singh Saran sir. He was from BHEL, and he has performed, or I mean, presented a very wonderful presentation consisting a full of information. So I think Vijay sir, it's all
Thank you,
good,
sir.
and
Thank you.
I think we should end it
Sir, I
here.
will be on behalf of you and the as a coordinator, sir, I will say that any query there, I am always eager to respond with the positive thought. And
Yes,
I
sir.
want to see some query from our fellow participants whosoever attending here.
Yes, yes, yes. Yes, sure, sir, sure, sir. So with this, I once again thank you very much, and now you can please leave. And about the documents, I'll talk about you later. So thank you, Vijay sir. Thank you very much. So dear participants, you please be here only. Actually, our next expert session expert, Dr. Subham Sahu is here. He is trying to join. I'm letting him in. Hello, Subham sir. How are you? Am I audible?